Hi guys, welcome back to the channel. So today we're doing the sliding window list. We're currently at the medium level problem. So since we completed 567, we'll go to the lead code 713. It is subarray product less than k. So the problem statement is given an array of integer nums and integer k, return the number of contiguous subarrays. Okay, where the product of all the elements in the subarray is exactly strictly less than k, guys. This is the one we are like this is the one uh, we have faced some problem with, which is in the k closest elements, and I think this is the one, longest substring with at least k repeating characters. Or is it? Well, I think arithmetic slices, or I didn't remember properly, so uh, we struggled for it a lot. It's in the playlist. The similar kind of problem you will notice when doing these problems, the familiarity or the similarity between the problems. So the problem statement is we are given an integer array named nums and the integer k. So we have to return a subarray where the product of all the elements in the subarray is strictly less than k. Okay, so the product should be less than the k, which is the integer. Number of okay. So I have to return the number of subarrays. So we will be going from 10 to 5, which is 50, and 2. 50 into 2 is 100, so which is not strictly less than 5. So we consider until 10 5. So we can get a subarray of length 2 and 2 subarray of length 3, I mean 1. So total 3 subarrays until here, and we'll go to next 5 to the 10, and 10 6 or 60. So if we consider this particular part, we will have a, one subarray of size 3, two subarray of size 2, and three subarray of size 3, which in total will give 1 plus 2 plus 3, which is 6. So also, oh, we forgot to mention, guys. So since we already considered uh, 5 as a single subarray, we cannot reconsider it again. So eliminating the 5 will give us 8. So then let's see what we can do. Slide it until we get to k. So the constraint is the numbers is between, well, it is 1 to, the length will be between 1 and 10 to the power 3 into 10 to the power of 4, and the numbers will range from 1 to 1000, and the k will be ranging from 0 to 10 to the power of 6, which is okay. Okay, so let's think how we should do this. The first problem I think is, so it's actually simple if we consider uh, this subarray, but we don't know whether or not we considered this as a single subarray. So let's do one thing. Uh, uh, we will consider we'll be considering all the subarrays whose size is greater than 1 for now, and we'll add all the subarrays of size 1 later, for which we have to do, like, we will keep a set. Let's do one thing. So elements greater than k equal to 0. So let's see. While so we're starting from here. LR is less than half months. And it's very good. So if num so far, let's see now. Port 6 here, -1. Let's see how we are getting arm and cell. Or we have to avoid this 3 part. No, so 0, 1, 0, 2. Oh, 0, 3. My God. Oh, oh, yes, we didn't. We are not doing the multiplication. From so far. So 1, 0, and 0, 1, 0, 2. We entered here and now it's on 3. 0, 1. Okay, 02. We have to avoid this part, for which we have to do -1, and after 1 3, 1 2 3. So 1, we should consider this one as the 1, and here 8. More than 2 lengths of R. Also, we will be taking 0 into 1. Zero 1. So R minus 1 is 0 initially. Oh, 1 1. Something is not going correct, guys, because right, where did right? So 0 0 2. Nice one. How did it skip 1 and 2? 0, 1, 2. So let's see. 0, 1, fine. 1, 2, 1, 3. So here we considered 1. Here 1, 2. Right. Right, guys. We are on the right track. So finally, here. What's it called? I'll explain, guys, what you are doing until now. But how? So we have to understand what's going wrong here. So let's try run now mine. So initially we take 1 and we add it 2. So 2 into 1 is while prod is greater than k. Um, the elements will be between 1 and 1000, right? So it should be edge case. Because it said the elements will be between 1 and 1000. If k is equals to 0, then it's edge case, guys. Let's add few more cases. Let's see. Right. So here is Is it should be greater than or equal to, so now it will work fine. So now so far is how if now so far is critical to the let's try submitting it and then check uh, our intuition. Then I'll explain the intuition. So let's try submitting it. Hopefully we did it right. We did it right, guys. But it seems there are many optimal solutions out there, and we did it in order of and time complexity. Well, I don't know. It's still fine. I'll explain the intuition for now, and let's start checking the remaining solutions. So what we are doing is we are initially handling the edge cases where if k is equals to 0, then we'll be returning 0 straight, and if the length of nums is 1, we don't need to check. Think we don't need to handle this case either. Let's try. Length of nums, right? Let's check this out. Yeah, we don't need the first edge case. It will make it look more elegant. So the first edge case, the edge case we're considering is if k is equals to 0, then since the constraint says the elements will be between 1 and 1000, we won't get any sum which will be less than 0. So we return 0. But if this problem involves negative numbers as elements, then this will become uh, another, like the toughness will become like go for another level. But for now the problem is simple. The intuition is, so this is we're counting all the elements that are greater than k. Remember for it right now, we'll explain what we are doing it with later. So we have kept a pointer at initial index which is 0, and another pointer right, which will be the one we are moving towards the right, and to check the number of uh, subarrays, we are keeping answer, and and to check the product, if the product is above k or not, we kept a temporary variable like prod. So we're moving right like this, and we are multiplying uh, like for every slide the element to the product like the prod, and if the product goes greater than k, then we are reducing the left bound, and since we are reducing the left bound, we are removing the like the prod value, the particular element from the prod, like undoing. If there are elements that are greater than k inside the list, we are counting it as I said earlier, and we are adding uh, like just see this guys. So if you consider this entire list as a substring, and someone asks you how many substrings can you derive from this entire string, then the substrings of size 4 will be 1, and the substrings of slides size 3 will be 1 and 2, and of size 2 will be 1, 2 and 3, and of size 1 will be 4, 1, 2, 3 and 4, right? So if you see the order, it is 1 plus 2 plus 3 plus 4, which will be the sum of natural numbers, n natural numbers, which is n into n plus 1 by 2. So we are doing the same. We are adding the n natural numbers here. Initially it will be r minus 1. If we take one step from r to l, then r minus l will be 1, and 2 steps r minus l will be 2, and 3 steps r minus l will be 3, and so on. So we are not adding the 4. If you like, as we said here, we are considering up to 3, we are adding 1, 2 and 3. So to add 1, 2, 3, 4, so to add 4, we are doing it in the last uh, in a array of size n, we will get n one sized subarrays, and since we don't want any subarray with value greater than k, we are counting all the elements that are greater than k, and we are adding it to here. So from the length we are removing all the elements that are greater than k. In this case it will be 4. In this case the length will be 3, and elements greater than 0 are also 3. So we are removing those 3. 3 minus 3 is 0. So I think you guys understand, and keep it guys. Work hard and we shall achieve our goal. Thank you.